Hello everyone. Today we'll start chapter 3. Yeah. Chapter 3 is about probability distribution, like one kind of probability distribution. What is probability distribution? It's a determination of all possible probabilities in form of a table, or sometimes it's like a form of a function as well. If the random variable is discrete, random variable, like the values is like broken values. The values are broken where the continuous random variable has the values with a range. If the random variable has some range from here, as I said in the previous sections, x is range from 2 to 6 something. If you have any range, then it comes under continuous random variable if the corresponding probability distribution is continuous probability distribution. What is probability distribution? Determining all possible probabilities, probability values in the form of table or else in a function. In chapter 3, we are going to discuss about discrete probability distribution. There are 7 probability distributions in our syllabus. The first one is general discrete probability distribution. Like the general, it's like same for every probability distribution. And this is discrete uniform distribution. There is one important trial, that is Bernoulli trial. The corresponding distribution is binomial distribution, and later it's a geometric distribution, negative binomial, and hypergeometric is non-Bernoulli trial, and lastly, very important, Poisson distribution. Okay, let's look into probability distribution function, PDF. Sometimes it is called as probability mass function. Remember these names because we'll get different names in chapter 4 and 5. Here we are going to discuss about PDF, probability density functions. The probability density function is random variable. It's like it's about discrete random variable. Discrete random variable. As the name itself says, continuous density function, random variable is continuous. Probability distribution of random variable x gives like there are 3 laws, very important laws. One is function of PDF always refers in terms of small f, whereas CDF refers in terms of capital F. Small f of x, or it is a probability of random variable, that is xi. This symbol is very important, equals to, for probability density function, always greater than 0. This is very important first equation. Small f of x is equals to, what does it mean? Probability of random variable that equals to xi, always greater than 0. And when we sum up all f of xi functions from I equals to 1 to n, it should be equals to 1. This is second important principle. And like it's like f of xi is equals to, this is capital F of xi. That means probability of x is less than or equals to. Whereas small f of x can be written probability of xi. Since it is small, equals to. Since it is capital F of x, it is less than or equal to. This is cumulative distribution function. Cumulative distribution function, CDF. And 0, this f of x value is ranges from 0 to 1. small introduction about f of x and small f of x and capital F of x. And very important topic regarding difference between small f of x, capital F of x. Okay. I have taken some data from your lecture PPT. Small f of x 0.6561, p of x equals to 1, 0.2916, p of f 0.0486, p of x equals to 3, that is 0.0036, p of x equals to 4, 0001. So the first statement is it should be greater than 0, and if we sum up all this, it comes 0.1. Okay. P of x equals to means small of x equals to 0. I mean 0. Small of 1, small f of small f of 3, small f of 4. When we plot a diagram, a graph, x, that is random variable, and f of x 0, I'll take 0, 1, 2, 3, and 4. For 0, the value is 0.6561. For 1, it is 0.2916. For 2, it is 0.048. For 3, it is 0.0036, and very small 0.0001 for 4. This is how it looks like for small f of x, that is PDF graph. Whereas now I'm going to write p of x less than or equals to 0, that is capital F of 0, p of x less than 1, that is capital F of 1, p of x less than 2, that is capital F of 2, p of x less than 3, and finally p of x less than 4, capital F of. What does it mean? P of, there is nothing before 0, so x equals to 0, directly 0.6561. This is p of x equals to 0 and p of x equals to 1. 0.6561 plus 0.2916, 0.9477. Similarly, less than 2 means x equals to 0, 1, and as well as x equals to 0.9477 plus 0.0486. It will use 0.996. After calculating f of 3, 0.999. This is 0, 1. So when I draw a graph between f of x and x, 0, 1, 2, 3 on x-axis, the values like 1, 0.999, 0.9963, 0.9477, and finally 0.6561. So the value of 4 is 1. This is 4. That is capital F of 4. This is capital F of 3. Capital F of 2. Capital F of 1 and capital F of 0. Right. This is the difference between PDF and CDF. So very important. And how to write this? P of x equals to 0 for P of x less than 0. I mean P of x, sorry, x less than 0 for x less than or equals to 0. Or else we can write it at from 0 to 1. The value is 0.6561. From 1 to 2, not equals to, it's less than 2, 0.9477, 0.9963 for 2 to 3, and finally 0.99932 to x 4, and 1 for x greater than or equals to 4. So When I study, how I remember is 0.6561 for x equals to 0, x equals to 1, 0.2916, x equals to 3, 0.0486, and x equals to 3, 0.0036, x equals to 4, 0.0001. First, write down the table, like where we can write f of x equals to 0, I mean f of 0 directly from the table 0 point. The problem with is capital F of x equals to 0, that is f of 0, right? I need 0. So from mark a point and draw sum all the values after that point, like from the starting point to the left, 0.6561. Like p of 1, I need this point. So what are the values? 0.6561 plus 0.2916. You'll get some value around 0.9477. Like similarly, I need this point, that is less than 2. What are 3 values are included? 0.6561 plus 0.1 plus 0.048. On total, it's the 0.99 something, 9999. So this is how I write mean and variance. What is mean? Everyone knows, like mean is the center of, this is the center point of probability distribution. A center point of probability distribution. For discrete random variable, mean is also known as expectation. E of x denoted with nu. It is summation of x into f of x, or summation of x into p of capital F of x. This is expectation of f of x. If we have function expectation of g of x, just replace x with the function inside the expectation. So whereas variance is square root, it is a square of standard deviation. Standard deviation is like a, okay, I'll tell detail in few classes. Standard deviation, it is denoted with p of x, that equals to expectation of x minus nu square. That is, if we apply this formula here, x minus nu square into f of x. Okay, we can again we can write it down as x square minus 2 nu x plus nu square. After applying e of x square, 2 nu will be constants, get outside, plus nu square is also constant, expectation of x. Expectation of x square, we know this is nu plus nu, this is 1. Expectation of x is 1. Expectation of x square minus 2 nu square plus nu square. Finally, you'll get expectation of x square minus nu square, or we can write it out x square minus expectation of x square. This is variance of x. We use both. We use this one as well as this one. So remember 2 formulas. And we know standard deviation is like standard deviation. We don't have any symbol for standard deviation. It is like variance of plus. Since this is inside the square root, standard deviation is always greater than 0. Important question. And we'll do a problem regarding mean and variance. This is a capital X equals to xi 0, 1, 2, 3, 4 values. So as I said earlier before, this table, expectation of x is very simple. X into f of x. Simply multiply with x and f of x. Summation of multiply x with f of x. 0 into 0, 6.6 plus 1 into 0.292 plus 2 into 0.048 plus 3 into 0.004 and 4 into 0.001. So we'll get around 0.4. And variance is x minus nu square f of x, or we'll find out expectation of x square minus, I know this formula, I know this value, and I need this one. Expectation of x square is summation of x square f of x. Just squaring the x values, multiply with f of x, and summation of both will give variance. Like 1 square into 0.292 plus 2 square into 0.048 plus 3 square into 0.04 and finally 4 square into 0.0001. After calculating, we get 0.52. This is expectation of x square. So what is variance? 0.52 minus 0.4 square, 0.36, and standard deviation will be root of 0.36, 0.6. A small problem regarding mean and variance. And like from this point, I'll describe what is uniform, like what is distribution. I'll give these three formulas: p of x, f of x, mean, variance for every distribution. Like in future, we'll discuss about discrete uniform, Bernoulli, geometric. Every distribution has three important formulas, that is p of x, mean, and variance. You should remember these three formulas for each distribution. Here, the major challenge is we need to find out which distribution we are going to use. Like there are some keywords in the question. Based on the keywords, you can recognize whether it is from discrete uniform or else geometric or hypergeometric. I'll give those keywords. It will help you in the examination. Look, the first one is discrete uniform distribution. The name says itself, it has uniformly distributed. That is equal probability. When I draw a graph between x and f of x, probability of 0 is some value, 1 some value, 2 1 value. So that is the value of probability is same for every random variable. That distribution is called uniform distribution. It's like p of x is simply like 1 by n, that is 1 by range. Range means from this point to this point. The inverse of range is probability for uniform distribution. Here equal probabilities, and in lecture PPT, Dr. Fred Tayari has taken example as he started a distribution from A plus 1 and so on up to B. So each random variable has same probability, that is P. So from here, what is range? 1 by range will be P minus A plus 1. Here very important, the plus 1 is why we are adding, like the range is B minus A, right? So what is range? This is range, B minus A. If we subtract B from A, we will get the range, but we are adding plus 1 for discrete uniform, and because we are including the inclusive, only one inclusive, like it will take a value. For example, I need this probability, so I need the range from A to B minus A, and I'm adding the value itself, that is inclusive. That's why we are adding plus 1. Whereas in continuous, we don't add the inclusive, like it's like B minus A. Second one is mean, that is new value, that is expectation of x is A plus B by 2. Expectation of x is A plus B by 2. And whereas variance is B minus A plus 1 square minus 1 by 2. And I have this the derivation of this formula. If you are really interested to know how it the verification, like the determination of this formula, kindly do email me. I'll send to you how, like, I have find out the formula for variance. These three formulas are important: f of x, mean, and variance. And we are going to very important trial, that is Bernoulli trial. Equal probability is keyword. Remember, Bernoulli trial. The trial having either success or failure. Either success or failure. Only two. Either yes or no. Either pass or fail. There is only one, like P or Q. P refers success, Q refers failure. In Bernoulli trial, the event has only two outcomes, either success or failure. That is Bernoulli trial. There are some important conditions for Bernoulli trial. The first one is with replacement. The experiment should do with replacement only. The first condition is with replacement. All problems involves, like, if you do a problem with tossing a coin or throwing a die, false Bernoulli's trial. If you have lot of experiments, if you have only one tossing a coin, throwing a die, it comes under Bernoulli trial. That is second one. Suppose there is a sample from infinite population with or without replacement. Here, as I said earlier before, like it has only with replacement. But if there is infinite population, we can consider without replacement as well. We can consider, this is rare case, without replacement. And finally, Bernoulli distribution will apply. Binomial distribution applies Bernoulli trial. Okay, let's see about a binomial distribution. Like it, as I mentioned before, any distribution has three values. One is P of x, f of x, and mean or expectation of x, and variance of x. We need to remember these three formulas for every distribution. F of x or P of x is NCX P n minus x, P power x, Q power n minus x, where n is number of trials and x is that particular event. P is success and Q is failure or 1 minus P. E of x is n into P. V of x is np Q. So if new value is greater than sigma value, sigma means standard deviation, that is root of npq, that refers to positive binomial distribution, whereas new value is less than sigma value, it refers to negative binomial distribution. So let's do one problem. You'll get an idea with binomial distribution. A box contains 4 red, 6 black. 4 red and 6 blacks of same size. 2 balls are drawn from random with the replacement. This is the first condition in Bernoulli. If gets red, it's success, or else it's fail. So it's considered as Bernoulli trial. So all conditions passed with replacement and either success or failure. Okay. What are the random variables here? Random variables are 0, 1, 2, Like we know that probability of success. What is success here? Getting red is success. Getting red. How many red? 4 out of 10. That is P is 0.4, but Q is 0.6. We know that. And number of trials is 2. Like 2 balls are selected. So N equals to 2 number of trials. So P of X equals to 0. I mean, what does it mean? 0 and 0 red. Like P of X equals to 1. I have taken 2 trials. Like first I have taken 1 ball. If it is black and another also black, P of X equals to 0. P of X equals to 1. If I taken a ball, if it is red, it is success, and the second trial must be black. Or else, like in the first trial it is black, the second trial must be red. In third trial, both are reds. So P of X equals to 0. That is 0. 0 reds. That is NCX P power X and 2C0, 0.4, X is 0, 0.6, 2. After calculating, you will get 0.6. P of X equals to 0 value. This is P of X equals to 1. 2CX 4 power. Like if you have good knowledge in probability in BTech, like how it came, we can calculate as first I have taken 4 out of 10 and 6 out of 10, or initially I have taken, and after calculating these values, you'll get 0.24 plus 0.24, 0.48. This is how we do in basic probability. The red one, black. Black one, red one. This is success, 0.4. Or we can directly put in formula 2CX 4 power 0.4 power 1, 0.6 power 1, 0.6. Same. P of X equals to 2. 2C2 4 power 0.4 power 2, 0.6 power 0, I think. Yeah, 0.16. After getting, we will write in a table. This is X value, P of X value. X are 0, 1, 2. For 0, it's 0 0.36, 0 0.48. So the first thing we need to do is making a table. I got table. From that, we can easily find out new value, summation X into F of X, variance summation X square F of X minus mu square. We don't need this one. We have directly NP, NPQ. If you have done this one, you'll get same as N into P. That is 2 into success 0.4, that is 0.8. 2 into 0.4 into 0.6, you'll get same 0.48. If you want to try, you can try using this formula, you'll get same as 0.8. So another important problem regarding binomial distribution. Okay, I might not have much time. I'll discuss, if I have time, I'll discuss this problem later. So the next distribution is geometric distribution. What are the keywords? If you need to implement geometric distribution, it has fixed success. The success is fixed. Number of trials changes. Whereas in binomial distribution, it's like trials are fixed, N equals to 2. Success is changing, 0.4, 0.6. So that is a binomial distribution. That is whereas in geometric distribution, success are fixed and number of trials can be changed. Okay, in a Bernoulli trial, there is a concept called P. Same will be applied here. For, as I said before, every distribution has 3 values: P of X, mu, and variance. P of X is 1 minus P power X minus 1 into P. 1 minus p and 1 minus p by p square. We need to remember these three formulas for every distribution. So the keyword is before success or before success. It's like the question will ask like, um, mm, here I'll explain an example. Before success is the keyword here. So that's why we are eliminating -1, the number of failures, first success, before first success. Before first success. I'm sure that no one will explain how to recognize which distribution is from, like geometric, binomial. So please remember these keywords before success, and before it was like success or failure with replacement. These kind of keywords are very important to find out which distribution it is. So let's see a problem. The probability that a wafer contains large particle contamination 0.01. Okay, the probability is 0.01. Directly he has given out of n equals to 125. Exactly 125 wafers need to be analyzed before a particle is detected. Here he said that before. So it comes under geometric distribution. So we know that P of x equals to 125, that equals to 1 minus p power x minus 1 into p. 1 minus 0.01 power 125 minus 1 into 0.01. You get 0.00287584. Okay, what is the question is, there are 125 wafers are there. You need to picking up each and every one by one. When you got, there is a one particle is damaged. If you got that damaged particle, you have to stop the experimentation. So we don't know when it happened. So that's why it is analyzed before a particle is detected. This is the probability out of 125, very less. And new value is 1 by p, that is 1.0.10. Whereas variance of x is 1 minus p by p square, that is 1 minus 0.01 by 0.01 square, 90. And standard deviation is root of 90, that is equal to, this is about geometric distribution. And next distribution is negative binomial distribution. So here don't interlink with the names. There is no connection between binomial distribution and negative binomial distribution. Geometric distribution, hypergeometric distribution, both are different. Here I don't know why they are mentioned the names like negative binomial distribution. The only connection is nu is less than sigma, that's it. Whereas first one is binomial is interlinked with the geometric, like the sequence binomial geometric. Now negative binomial, and later it will come with hypergeometric. This is the sequence. Okay, negative binomial. Here the trials are independent. In this distribution, trials are independent and with constant probability. The getting success is same. Getting success is same, constant probability. So as I said earlier, f of x equals to x minus 1, c r minus 1, p of r q power x minus r. New value is r by p, and variance is r into 1. The only difference is, like in geometric distribution, he'll say that you need to stop if you got the first success, or else before detected. Whereas in negative binomial, it's like you need to do the experimentation until you got r trials, r successes, like 3 failures, 4 failures, or three successes. That is how they ask. The question is the probability that a camera passes a particular test is 0.8. The probability is 0.8. Here the success is defined 0.8, where the probability is third failure. He mentioned that some r equals to 3 obtained out of 5, n equals to 5, r equals to 3. So just what is question? P is equals to 0.8 and Q is 0.2. So he is asking P of x less than 5. What are the chances? P of either, I'm sorry, P of x. Okay. Up to third failure, there is from third trial, fourth trial, and fifth trial, we need to find out the probability, like from third or in fourth trial or in fifth trial. Simply put all those values 3 minus 1 C, 3 minus 1 0.2 power 3, 0.8 power 3. After calculating, you get 0.5792. So I'm stopping here. It's negative binomial. And in next sections, we'll discuss about non-Bernoulli trial, hypergeometric. I'll give a new technique for hypergeometric rather than what Dr. Fred Tayari has taught in your class, and a problem, and very important, Poisson distribution. There is some approximations. Okay. That's all from my side. If you have any questions, kindly let me know. I'll be at BCC 4232 from 3 to 6. Any questions?
Vishwa, can you send the keywords like how to recognize this? You said
Definitely, I'll send those. When is your exam?
first
It should be on March 6th.
March 6th. Okay.
Yeah.
Okay. Sure. I'll ask Dr. Fred to share my cheat sheet. My cheat sheet has everything inside. Like I have written how to recognize the probability distribution, and I'll ask him once whether he allows me to share my cheat sheet to all. Definitely, I'll share to you. You'll get an idea. As of now, I think you'll get a better understanding, like how to recognize what is distribution, probability distribution, and out of discrete probability distribution, we have multiple like uniform, Bernoulli's, binomial, geometric. You can easily find out. If you have any questions, let me know. That's all from my side. Thank you so much.
Thank you, sir.